Welcome everyone. Today I'll be talking about how CircleCI and ARM virtual hardware can work together to support your company's needs. Before we dive into the agenda, I want to take a moment to introduce myself. My name is Jim Crowley and I'm a solutions engineer at CircleCI. I work with customers and the open source community to solve problems that developers face. Today's agenda will be going over a quick overview of CircleCI's platform, followed by taking a look at CircleCI's self-hosted runner, then seeing how CircleCI can help integrate with ARM virtual hardware, and then lastly some resources and closing notes. Here at CircleCI, our mission is to make it as easy as possible to go from idea to delivery, allowing customers to move as fast as they want when delivering their products to their customers. CircleCI has seen tremendous growth from our founding in 2011 to now. We support a wide range of customers from SaaS platforms to big financial institutions. CircleCI can be configured with a simple YAML-based file, which allows customers to build, test, and deploy applications securely and quickly. CircleCI sits between your source control system and deployment environment. When a developer checks in their code to their source control system, CircleCI will pick up on a webhook, kick off a pipeline based on a configuration file. This configuration file allows developers to control what actions they need to take to build, test, and deliver their code. CircleCI also has a rich ecosystem of various partners and integrations that make getting up and running extremely easy. CircleCI provides three main ways to interact with our platform. The first is our cloud platform, which allows you to fully focus on your products. Gone are the frustrations of hosting and managing your own continuous integration and continuous deployment system. Circle takes care of scaling your build environment by telling us what environments you want to operate in. CircleCI has many different operating environments such as Mac OS, Windows, Linux, Docker, and more. Second is our server offering, which allows you to get the best-in-class CI and CD system hosted on your own infrastructure. With our server offer, you are able to get fully in control on how you scale and operate your own infrastructure. Lastly, CircleCI also supports a hybrid model, which allows you to use our cloud platform and have a self-hosted agent in your own infrastructure. CircleCI's runner offering allows you to use your own compute in your own environment. Runner is extremely helpful when you have a resource on your network that you do not want to expose to the internet, or you have unique hardware that you need to do testing on. The latter is the portion we'll focus on today to achieve integration with ARM virtual hardware. Let's take a deeper dive into CircleCI's runner offering, as this is the primary way customers will be integrating with ARM virtual hardware. CircleCI's runner works by having a customer install a binary onto the machine they want to do work on. Once installed, the runner agent will pull for any job that is assigned to a given resource class. Once a job is assigned, the runner agent will pull down the job and execute the job. Whether a customer is using our cloud platform or their own machines, they'll have a nice dashboard to view everything that's happening within a given job. A customer will be able to see output in real time and have the ability to rerun the job with SSH to do live debugging. Now we have the basics understanding of CircleCI's cloud platform and our runner offering, we can jump into the demo. The demo will cover two different use cases. The first will cover the standard runner install and operation with ARM virtual hardware. This approach will have customers spin up a persistent ARM virtual hardware instance and have CircleCI's runner installed on it. The second use case uses an on-demand approach. Using the on-demand runner orb, CircleCI will spin up an ARM virtual hardware instance and install CircleCI's agent automatically. Once the instance is up and running, a customer can do testing, then CircleCI will spin down the instance after all testing has been completed. This approach saves customers money by not having the instance idling on AWS. Welcome everyone to use case 1. Use case 1 shows off a standard runner install and uses with ARM virtual hardware. For the sake of time, I've gone ahead and completed some of the steps beforehand, but all documentation and links can be found in the resource section of the slide deck. Before we jump into installing the runner, I wanted to go over quickly how to install an ARM virtual hardware instance on EC2. This page right here shows you how to subscribe to the ARM virtual hardware AMI. Going through and clicking this button right here will walk you through how to spin up your own instance. Over here on my AWS dashboard, I have an instance already spun up called ARM Virtual Hardware Live Demo. If I go ahead and grab the IP and hop over to my terminal, I can SSH in. Before we start issuing any commands on the EC2 instance, let's go back and take a quick look at CircleCI's runner install docs. Now, when installing runner, you'll need to create a couple different things. First is a namespace. A namespace is unique to your organization and does require owner/admin permissions to be created. This is the command right here on how to create that. Once created, you'll need to generate a token and a resource class. This is the command to generate those. A resource class is a way to target a specific group of runners. For this example, we'll have one runner in the resource class, but you could have more. When creating a resource class, make sure to give it a descriptive name. After issuing the command, you'll be given a token. Please hold on to this token because later in the install process, it'll be needed. Now we got that out of the way, we can start issuing commands on our EC2 instance. Down here, this shows off how to install the launch agent, which is the CircleCI self-hosted binary. Go ahead and issue these commands. You'll need to customize them to fit your different platform and run through them. After you've done that, go ahead and follow the Linux install docs. On this page, you'll set up the runner config along with some permissions. When looking at this config, keep in mind you need to change some values. The first one is this auth token. This token will be the token we got from the previous step when generating a resource class. The second is the runner name. The runner name will be customized to something descriptive. And lastly, since ARM Virtual Hardware has all its tools installed for the Ubuntu user, we'll need to tell the runner to run as a Ubuntu user instead of a CircleCI user. On line 8, you can change this right here to Ubuntu instead of CircleCI. Once you copy this config and customize it, go ahead and save it in ops circlecI/launchagentconfig.yaml and make sure it's owned by root. You can change the permissions running these commands. Next, you'll go ahead and create a user and a working directory. That's for a normal install. But since we're using ARM Virtual Hardware that has all the tools installed on Ubuntu, we'll be not creating the CircleCI user, but we will still need to create the working directory and also change the permissions of that directory to be owned by Ubuntu, not CircleCI. After that is done, we are very close to being done with the install of the runner. The next is creating a service that will start the runner upon starting the EC2 instance or shutting down the EC2 instance. We'll be doing this through systemd. Go ahead and copy this config in this given path right here. Make sure it's owned by root and have these permissions. Once the service is installed, or basically made a file right here, you'll go ahead and enable it. Once it's enabled, you can run this command to start the service. Now, if I hop over to my instance, one of the commands we can verify the service is running correctly is by typing systemctl status CircleCI.service. Now, if you see that the service is active, that means you are doing well. If I come over here and use the arrow keys, you can see that the CircleCI config got loaded in and there's no task found right now. That is normal. Once we issued a workload to this runner, a task will be found and operated on this runner. Now that we have runner up and running, we can come over to our example. For this example, what we're going to be using is the microspeech example given to us by ARM. In this example, I changed and added a CircleCI folder. In this folder, we have a config.yaml. This config.yaml is what controls what job are going to be ran on that given runner that we just created. On line 6 here, you can change it to your namespace and your resource class that you created in the previous step. If you leave everything else the same, everything should work just fine. Now, if we come over to the CircleCI UI, I'm able to go to the project, microspeech, and able to come up here and do trigger pipeline. This will go ahead and run a new pipeline on the runner that we just spun up. The nice thing about the CircleCI UI, we're able to see historical builds and look at the output, but also see the live output from real builds going on right now. This is the build I just kicked off. We can see that I'm using my custom runner that I spun up. You can see that we downloaded dependencies for the microspeech example. We are working on building the microspeech example. Going back to the project overview, I can see past builds and see how long they have taken historically. Right now, it looks like we're about at 2 minutes for building and testing the microspeech example. If I look at the historical build, I can see that I installed dependencies, built the microspeech example, and then ran my test cases. Going back to the other example, we can hop in and look at the live outputs. Right now, this is building the microspeech example. We are almost done with all the steps needed to build it. Now note, this is running on the runner. This is not running on CircleCI's cloud instances. We can see this denoted by the executor up at the top, and we can see that it is targeting my runner. I can go down here and see that the test ran in 6 seconds, which is really, really fast. Once again, all the links and documentation are in the resource section of the slide deck. Welcome everyone to Use Case 2. Use Case 2 shows off how to use ARM virtual hardware in an on-demand way. Instead of having your instance idling, costing you money while not in use, the on-demand approach only spins up a resource when it's requested. After work is done on that AWS instance, it will be spun down to save money. The only drawback is the time you'll have to wait until the on-demand instance is up and running. In total, the on-demand approach adds roughly 5 minutes to the overall pipeline time. Before we dive in, we need to take care of a couple prerequisites. One of the prerequisites we'll need to do is make sure you're subscribed to the ARM virtual instance. The next thing we'll need to do is go over to the runner install docs and make sure you generate a CircleCI namespace. Once you generate the namespace, make sure you keep that namespace handy. The next thing we're going to do is go ahead and generate a CircleCI personal access token. Generating a CircleCI personal access token is very simple. Go ahead and go to your user settings, go to personal access token, go ahead and create new token, add a token name, and then click on add API token button. What will appear is a token, a random string. Go ahead and copy and paste it into a secure location. We'll need it later for the install. So how are we going to achieve this on-demand flow? We're going to leverage an orb called on-demand runner. Orbs, for those who don't know, are prepackaged pieces of code that make your life 10 times easier. They allow for quick and easy integrations with third-party services. The third-party service we'll be integrating with today is AWS and ARM virtual hardware. Since we'll be working with AWS, you need to have access to your access key ID and secret access key. So keep that in mind as we go along. One of the things you'll see on this on-demand runner is CCI Labs. That stands for CircleCI Labs. And if we scroll down, we can see the users example. And we can see two jobs that go with it. Deploy, which is go ahead and spins up an EC2 instance. Here's some values that we'll need to set, which I'll go over in a second. And then destroy is the second job, which will go ahead and spin down that EC2 instance that we spun up earlier. Now, there's a couple things we need to do before we can get to the install. One of those things is going to organizational settings, going to context, and making a context. A context is a way you can share certain credentials across many different projects. For this example, we're going to create a context called AWS Creds. And in that AWS Creds context, we're going to create 3 different environment variables: AWS Access Key ID, AWS Region, and AWS Secret Key. Now these values need to stay the same right here, but the values over here, aka the values that you have, will be different. So you need to input your Access Key ID, your default region, which you want the EC2 instance to be spun up in, and then the secret key associated with your account. Once those are configured, we'll move on to the environment vars. Now to get access to the environment vars, we're going to go to project settings, go down to project environment variables, and then you'll see something that looks like this. On your project, it'll probably be empty, and we need to add all these values you see here. Now these values aren't anything crazy. They're all basically control what instance gets spun up and how that instance actually works. For the first environment variable we need to add is the AMI ID. Now this AMI ID needs to correspond to the ARM Virtual Hardware AMI ID. You can get that from a running instance or the AWS Marketplace subscription page. Once you have that value, go ahead and paste it in. The next is the AWS instance type. This is what kind of size you want for your EC2 instance. Go ahead and pick out a size that meets your needs and put that value in here. AWS Security Group ID. This is a security group you want attached to the EC2 instance. Whatever security group you do assign to this EC2 instance, make sure SSH is open because we'll need that for the install. Next is the AWS SSH key. Make sure you reference a key that's available to you on your AWS account. CircleCI namespace. This is going to be the namespace we generated previously. CircleCI token, that's going to be your personal access token, which we generated previously. And then a runner user. This runner user is going to be Ubuntu. That is because on the ARM Virtual Hardware instance, Ubuntu is the user that has all the tools installed. So when we run the runner agent on this instance, we want to make sure we can tell it that we need to be running as Ubuntu. Now for this AWS SSH key, this is very important. One of the things you'll see over here is the SSH key tab. How this orb is going to work is it's going to contact EC2 to go ahead and spin up an ARM Virtual Hardware instance. Then it's going to go ahead and SSH into that brand new instance and go ahead and install the CircleCI runner agent. Now how can it access and actually SSH into that instance? We need to go ahead and upload your SSH key over here. So make sure the SSH key you reference here on your AWS account is the SSH key that you do upload over here on CircleCI's project settings. Once you have that squared away, we are pretty much good to go. Let's go ahead and take a look at the config I have set up. If you go to the microspeech example I have, instead of going to the use case 1 where we went to manual runner branch, we're going to go to the CircleCI branch. Now in the CircleCI branch, we have the .circleci folder. Inside that folder, we have a config.yaml. Now this config.yaml looks pretty familiar. It looks pretty much similar to the other one. There's a couple of key differences. And I also want to note there's one change in this file that you should and need to make is on line 9. Make sure to replace the namespace with whatever namespace you created instead of my namespace. Go ahead and please leave the pipeline ID that is needed. Just change the namespace name. Now down here, the things that changed is we're not just running the microspeech example job, we're also running this on-demand runner deploy job and on-demand runner destroy job. Again, the deploy stage is going to spin up that EC2 instance, and this instance is going to be the AMI of the ARM Virtual Hardware instance. So we're going to spin that EC2 instance up, then go ahead and run a job on it, and then go ahead and spin the instance down. With that out of the way, let's go over to the CircleCI UI. We're going to the My Microspeech Example project view. Now, if I go ahead and hit Trigger Pipeline, it's going to go ahead and trigger a new build of this job. If I go ahead and hop into this deploy stage, we can see that set up with an environment. And this is going to go ahead and contact AWS to spin up the EC2 instance based on those environment variables and AWS creds we set. It knows what it needs to do. What we can do is actually go ahead and look at the old one, the previous run here. Oh, might misclick there, my bad. Previous run. Now if I go down here, you can see the provision on-demand runner. This is going to go ahead and contact EC2, go ahead and spin up your AWS instance. Then the following job, right here, or following step, my bad, is going ahead and SSH into that instance that we just spun up and go ahead and install the CircleCI runner automatically for you. And if we go back, the next job after that is go ahead and run the microspeech example. This is the same example we saw in use case 1, but we are running on a dynamically spun up runner. And then the last job over here is going to be terminating the instance that we just spun up in step 1 after we do all our testing and after we don't need the instance anymore. Now this is extremely helpful again when cost is a big factor. You don't mind spending a little extra time spinning up the hardware and destroying the hardware to save some money. Now if time is really of the essence to you, then I would recommend use case 1. But if money's on the mind, this use case 2 makes a lot more sense. Now, if you have any questions, feel free to reach out to me, and I'm happy to walk you through it or have a more in-depth discussion. Again, all these resources and everything I showed here is going to be in the resource section of my slide deck. Thank you for coming, and I hope you enjoyed both examples. With the demo out of the way, I wanted to highlight the resources I covered in today's demo. These links cover all the documentation and examples we covered today. The first link is the link to the AWS Marketplace where you can sign up for access for the ARM virtual hardware. The second link shows you how to set up ARM virtual hardware on AWS. After setting up your instance, you want to follow the install instructions for CircleCI's runner on Linux. If you're looking for the configuration code I showed off in today's demo, you can follow the link to the microspeech example. Lastly, you get the links to the on-demand runner orb. The orb registry page will show you how to use the orb. The second link here will show you the source code for the orb. I want to thank you. I hope you enjoyed today's demo. It's been a pleasure to show you how CircleCI and ARM virtual hardware can meet your company's needs. If you have any questions, please refer to my contact information on the second slide. Thank you.